Okay, here is the agenda for today. We're going to be covering our periodic table notes, and then you will have a homework assignment. I'll talk about that in a moment. So let's go ahead and all right, so you have a note sheet in front of you titled Periodic Table Notes, and as we go through, you're going to be filling in the blanks of your notes, but you should also be able to help me with these notes based on some of your former knowledge, and then just based on looking at your notes. So and then the song also should be able to help you. So if you know the song, you really pretty much know your notes, and it will help you all the way through as we start to get a little bit deeper and a little bit more difficult in our chemistry. So you have a table that looks, your paper, your notes that look like this. First of all, before I do that, how many of you were able to fill in a lot of your elements without looking? Good. And if you need to be studying them daily, maybe putting on Quizlet and just kind of like on your downtime, really quickly on the bus, go through it on your way to practice or wherever you're going, while you're in the car. Quickly look through that. Even while you got your music going, you can be looking through it on Quizlet while you're listening to your music. But, all right, so let's go through here and look at this. The periodic table is an organization of what? Raise your hand. Rosalind. It's an organization of elements. I don't know why the word horizontal is there, but it should say elements. Make sure you write elements, not horizontal. So it's an organization of elements. And it is increasing by a specific number. And the song, she says, blank, blank, number 1, 2, 3, organize the table periodically. Atomic number. And that should say number. Goodness gracious. Make sure you write atomic number there, not atomic mass. I will fix it. But it is increasing in atomic number, and it is grouped according to similar properties and the electron arrangements, which we'll talk about in a little bit as well. It's organized also horizontally. Is horizontally going side to side or up and down? Side to side. That organization going side to side, she says it in the song as well. I believe she says it in this song, unless I said it in another song. Then what is it? Nope. She doesn't say it in this song. But these are your periods.
No, she said the period is just.
Yes, you're exactly right. I knew she said in this song. In horizontal are rows. Going side to side are rows. So period is just a term for a row. So there's your periods going horizontal. Maybe underneath you might want to write row. Underneath the word period. So that'll help you out. And so when you see the song, you know my rows are my periods. They go side to side. And she says going up and down, that's vertical, right? What are those? It's vertical, but then she says something about in the next sentence. In your song. Thank you, families. She says, atomic number, count on 1, 2, 3, organize the table periodically, going up and down similar properties. Families are tight. Elements are easy. Your families go up and down, and that's your vertical. It's going up and down. That's also known as a group. Underneath, you might want to write families as well. Because your groups are your families, your periods are your rows. And you'll hear them referred to as periods. You'll hear them referred to as rows. You'll hear the part that's going vertical referred to as families or groups. Looking at your periodic table, how many periods are there? Looking at your periodic table, how many periods are there, Rosalind? Periods. 7. Periods, that's rows, horizontal, going side to side. There's 7 of them. 1, 2, you see that? And I was going to go to the next one. You don't see it?
I see it.
You understand? Everyone understand? Okay. All right. So now, we have some major contributors to the periodic table. This particular person in 1800s, he's a Russian scientist, and he developed the periodic table. What happened is, he was thinking, he saw these elements, he started studying them, he said, oh, these are kind of like organized, 1, 2, 3, 4, 5, like this is really awesome, and he started putting it together, instead of having it all sporadic, he saw that once we put them together, these are similar properties, wow, this is pretty awesome and pretty neat, and that was, Rosalind thinks she knows? No, not the one that developed the periodic table, it's a scientist named Dmitri Mendeleev.
Oh, yeah.
Make sure you're filling in your notes. Dmitri Mendeleev. The one that's responsible for the atomic theory. It says they all said they're atoms. Some said so. That's from the song that I wrote. Who is it? John Dalton said so. So underneath, we're writing the atomic theory. The atomic move up then if you can't see. Raise your hand. Don't sit around and whisper, I can't see. Oh. The atomic theory states that everything is made of atoms. That's what you should be writing under there. Everything is made of atoms. That is what the atomic theory is. We break down elements. It's made up of a bunch of elements, a bunch of atoms of that element. Remember, elements are pure. Atoms comes from the word atomos. That's a Greek word. Atomos means invisible. It did not pop up. Next to the Greek, write invisible. It says Greek equals invisible. The reason why I tell you that is to help you know what atoms are. We can't see atoms. So we think that they are invisible, but they're not. They're there, they're just very small that we cannot see them. Now we're going to talk specifically about elements. Now elements are pure substances and they cannot be separated. That's what we talked about before. We all know that. They're arranged on the periodic table according to their what and what properties, everyone.
Chemical and physical properties.
Chemical and physical, or physical and chemical, however you want to write it. Yes.
I'm an eraser I can use. My pencil Thank you.
We're good with this? So here you have your periodic table. Here we looked at them. They're all arranged. We see that information here. We talked about our periods, just a term for a row. They go side to side, which is horizontal. Your groups, also known as families, go up and down or vertically. So how many do you have there? 18. All right, so we're good. Atomic numbers, count them 1, 2, 3. Organize the table periodically. All right, so now elements can be broken down or described 3 different ways. We're going to start with one of the major ones, and then we're going to go down to the more and more. So metals is the one. Where are metals found on the periodic table as opposed to left, right, or in the middle? Where are your metals? Metals are not just in the middle. They are on the left side of the steps. You have something called the steps. That's that dark broken line there. You see that? Those are your steps. So when we talk about the left, we're talking about the left of the steps or the right of the steps or that indentation down in the middle. So your metals are found on the left. Except for one particular element. It's on the left, but it is not a metal. Hydrogen. It is a gas, which is also known as a nonmetal. Question?
What about the 2 periods that are on the bottom?
We'll talk about that in a moment. Some properties of metals are listed there. They're good thermal and electrical conductors, meaning they can transmit heat and electricity. They have shiny surfaces in appearance, and they're ductile and malleable. What does ductile mean? Duran?
You should be able to like bend it.
No? Okay. What is duct tape? But can you pull it out apart?
No.
No, not pull it off of something, but when you start taking it apart, what does it look like?
Sticky.
What does it look like? Sticky is a feeling, little strings. The reason, well, when you look at it, it's like made of all these little, yes. So, those look like little wires, right?
Yeah.
Ductile means it can be put into a wire. That's why it has the term duct tape, because it's made of all those little strings. So ductile means it can be put into a wire, like your copper wire and your gold necklaces and things of that nature. It can be put into a wire. That's what ductile means. So metals can be put into wires. What is malleable? Jenny?
Malleable means it can like bend and everything.
Nope, not bend. That's not quite what malleable means. You can bend it, but that's not what malleable means. It can be pounded into flat shapes. Think of a mallet. What would you do with a mallet? You pound something flat. And so that's what malleable is. Now you have your transition metals. Where are your transition metals? They are found on the left side of the steps, but where on the left side of the steps?
In the middle.
In the middle. I want you to also write group 3 through 12. You also have something called alloys. Alloys are not on the periodic table. They are not metals on the periodic table. What they are mixtures of two or more metals to give it a stronger property. So, for instance, gold is very malleable. We might want to have a metal that is going to be a lot stronger than gold, but not too strong that we can't do something with it. For instance, we might want to make a piece of jewelry, but we don't want it to be very malleable, and there's not quite a metal to give you that. And you don't want to walk around with a tin bracelet, because that's really strong, but you wouldn't want to walk around with that. So therefore, they mix metals together to give it a stronger property, or a property that doesn't have of its own. So that would be an alloy. What kind of mixture would this be if it's a type of mixture where you cannot see all the different metals that it's made up of, Patrick? This would be a homogeneous mixture. And examples for this would be things like bronze and steel.
I have a question. When they mix the metals, is that what makes your skin turn green? Because they mix the metals?
This could be allergic reaction. No, not even allergic reaction. It could be reactive. Not what turns your skin green because they mix it. It's because it's reactive with whatever, the water, you're sweating, or the air.
They get alloys from the word allies?
No.
Well,
And you could have an allergic reaction, going back to Drika's question, because your body is reactive to the element that you're not. You can't wear that, whatever it is. You have another question? Okay. All right, moving on from here. So there you have your metals on the left side. Everything on the left side of the steps are metals. But down here you have something that's called transition metals. What's wrong, Drika and Christasia? All right. So now moving on to your nonmetals. Your nonmetals are found where?
On the right.
On the right side of the steps, on the right of the periodic table, except for hydrogen, which is found where?
Left.
On the left. Make sure you're filling in your blanks. These properties, some of them are gas, not all of them, but some of them are gases, which make them a nonmetal. They are poor electrical and thermal conductors, meaning they do not transmit electricity or heat. They are dull in surface and appearance, so if it's a solid, they're going to be very dull. They're not going to be shiny like sulfur. And very brittle. What is brittle again?
It's easily broken.
Easily broken. Then you have your metalloids. These are your semi-metals. Where are they found?
On the bottom.
Right.
No.
In the middle.
They are found along the steps.
Oh. That's aluminum.
That's why they have the properties. They're something like a metal, but maybe not like a metal. So they're right in the middle of that. There would be that step, meaning that they're somewhere close to the nonmetals and really close to the metals. They're on the fence. They're on the step. So they have some characteristics of metals and some characteristics of nonmetals. So they may be shiny, but brittle. They may be shiny, but not a good conductor of electricity. Or they may not be shiny and be a good conductor of electricity. Well, give me an element that would be a metalloid. Looking at your periodic table, Janie. Aluminum. How many of you have put aluminum in the oven? How many of you have touched it after it came out the oven? How many of you have burned yourself on aluminum?
No.
Not
You
quite.
can't burn yourselves.
Aluminum is not a good conductor of heat, so therefore,
No, like it gets hot.
it gets hot, but it's not going to be hot enough to burn you.
Aluminum
Like
can.
I get like something red on my finger.
Yeah, but and then it goes away. It's not going to be like if you touch stuff hot and you get a blister. It will have some heat, but it's not gonna be a very good conductor. All right, silicon is also another, metalloid. Silicon is not shiny, but silicon can be, is a good conductor of electricity. You have silicon wires in your phones, your cell phones. There's silicon wires in your computers, because it does conduct electricity.
So what about the one that says, and the one that says in boron? And
Boron is not. It's on top of the steps, not along the steps.
What about the
The who?
it's a U, a lowercase u, and a H.
Uniception.
It says,
Out of those, no, that's not, that's down past the steps. That's a very rare metal, that's why it looks clear. All right.
Wait,
Yes.
is this silicone waterproof?
Yes.
Because
silicone what? Is silicone
Waterproof.
What is silicone used besides concentration?
I just said, it's in your phones and in your computers. All right. Again, they may be shiny and maybe dull. Silicone is not a shiny metal, but aluminum is, and they swap kind of properties. All right. So your metalloids are along here, along the steps, along the black part, minusing the UUH and the UUS and minusing boron. Those are not along the steps. All right? Edison, stop talking. Your special rows. These special rows, there are two rows of elements that are located at the bottom of the table. And they are placed there for a specific reason. So they don't make your periodic table look too long. Now, if we look at your periodic table, you will notice that's these two rows down here. What are they called?
lanthanide series and actinide series.
Lanthanides and actinides. You can just call them that.
When I discovered where the name was, like American.
Yeah. Some of them have scientific names. But not the scientific. All right. So if we look at our periodic table, the reason why they are located down here, notice how nice and compact your periodic table is if we put them down there, right? But if you look at the number for 56 is uranium. No, it's not uranium. Barium. I couldn't read it. 56 is barium. And then if you jump that space, what comes after that? Number 72, right?
Yeah.
But if you look at the first lanthanide, which is 57, that comes right after 56, right? If we look at radium for number 88, you see that? If we look down at the actinide, that's 89. These entire two rows fit up in that blank space. But if we put them there, our periodic table would stretch out so far. It would be too big. So therefore, the scientists that developed it said, well, these are really, really rare. Although they do fit in number because they do have these atomic numbers, they actually don't fit in properties with this. They have their own properties. So it's easier to pull them out here, and it just makes sense. But we do understand they still fit that way. So that's how the periodic table is developed. They do still belong, but they're very rare.
Aren't they supposed to be like a clear? Since they're like man-made?
No, not all uranium's not man-made. Not all of these are man-made.
It's like all of them are gold.
Yeah, they're rare. They're not man-made though. All right. So now if we look on the back of our paper, you have your periods versus your groups. This helps you understand how the periodic table is placed, and it's going to help us as we go deeper into chemistry. Your periodic table contains the periods and the groups. Periods are also called rows, and they are how? How are they going? Horizontal. Groups are also called.
Family.
How do they go? Vertically. These are your columns, rows, columns, rows, periods, horizontal, groups, families, vertical, columns, and they go up and down. How many periods do you have?
18.
7.
Oh, 7.
How many groups do you have?
18.
18. There are 3 things that identify the element on your periodic table. The things like H, P, O, Q, N, E. What are those called?
Symbol.
Thank you, right?
Roger Lynn.
Dang.
What are they called?
Element symbol.
Element symbols. The number of protons are also identified on your periodic table, and that is called the what?
Atomic number.
The atomic number. And the number of protons, and which also equals the number of neutrons, plus the number of neutrons, would be your atomic mass.
Not by subtraction.
You do not subtract them. You add.
What?
I'm sorry, I'm not concerned about that. I'm telling you what it is right now, and you will see all together. They're added together. It's the mass. You do not subtract it. The atomic mass is the protons plus the neutrons, and when you see your picture, you will understand it a lot better. All right. Any questions on this? Okay. So here we have your periodic table once again. Your element box are identifying your atomic number, which are the 1, 2, 3. It also identifies your element symbol. They don't always have your element name, but they do have the element symbol, which would be the letters. Then it also has the atomic mass, which is the bigger number. There's no way you could subtract it and get a bigger number. You would get a smaller number. Well, I'm just telling you now what it is. All right. An atomic or atom, or also known as an element, is made up of 4 things. We're going to go through them right now. The atomic mass is the center of the element. This is called the what? The center of the element.
Nucleus.
This is your nucleus. And it should be NU, not NEU. NU. Spell it correctly. Might take that first E off. It's NU. CLEUS. Problem is my delete button on my computer does not work, so I have to always cut it and it's just all right, this is made up of this and this. This is the bigger portion, the heavy portion, it's the mass. So it's made up of this and this. What is it?
Protons.
Protons and neutrons. The mass. And remember you learned mass in when we talked about the hydrosphere, we learned about the mass. The mass is the heaviness of it, what it's made up of. And your nucleus is made up of your protons and your neutrons. That's your atomic mass. The atomic number is protons. What type of charge do the protons have?
Positive.
Positive. Protons. Positive. Protons. And if you got to say that in your head to remember, do it. That's how you remember it. Even if you look stupid doing it, so what? That makes it easier to remember. All right, where are they located? Protons are located in the nucleus. So far, our element, or our atom, is made up of a nucleus. It's made up of protons. Then this portion has a neutral charge. These will be considered the what? Neutrons. And what type of charge do they have again?
Neutral.
Neutrons?
Neutral.
Neutrons? Neutral. Neutrons? Neutral. Got it?
Yeah.
Where are they located?
In the nucleus.
In the nucleus. Then the last part of an atom. Now, how many of you remember watching Jimmy Neutron when you were little?
Me.
And when he gets a brain freeze, what pops up?
Oh no, it's going side.
And there's an atom.
Yeah.
There's a center portion, which is the nucleus with the protons and neutrons, and then there's what?
Electrons.
There's that stuff orbiting all around. That would be your electrons. Your electrons are equal to the number of protons. So however many number of protons you have is the same number of electrons. You should not be doing side talk because the brain turn around. What type of charge do the electrons have?
Negative.
Electron? Negative. Electron? Negative. Look how my face looks the same when I say it. Electron? Negative. All right. Don't try to say electron. Try to say N so you can get it. All right. Where are they located?
Electron
cloud.
Which is orbiting or circulating the nucleus. Why do you guys feel like I said it first? You're in 8th grade. That is a characteristic of a 3rd grader. All right? Any questions about that? Okay, so then you have a picture. Now your diagram here is a diagram of an atom. Next to this, you can also put AKA electron, AKA element. Next to atom, you could put AKA element. So this will be a picture of an element atom. Now your very first box is pointing to or looking at this bulk of the stuff in the middle. What is that?
Nucleus.
That is your nucleus. Your nucleus is your mass, correct? That's what it's made up of. In the middle, it's made up of your protons, which has a positive charge, and your neutrons, because they have no charge. Now, before we move on, your protons have a specific mass per se. That would be considered the what? The atomic number. Now, remember, your nucleus is made up of your protons and your neutrons. Your nucleus is also considered your atomic mass. If your mass is made up of the atomic number and your neutrons, do your neutrons still have, do they have a weight or a mass?
No.
How do they not have a mass? Listen to this. How do they not have a mass if the atomic mass is larger than the number of protons? Go back to your periodic table for a second. Let's go back to our periodic table just for a second. If we look here at lithium, which number on lithium is your atomic mass? 7. Which one is your atomic number? 3. Now listen, before you answer the question. Your atomic mass is made up of what? Protons and neutrons. What is the mass of your protons? Your atomic mass, I would expect better from this group, you guys are in a higher mass, is your protons and your neutrons. Correct? If we're looking at lithium, what is lithium's atomic mass? 7. What is the atomic number for protons?
4.
We do not know what that number is unless we do the math, which would make it 7 equals 3 plus an unknown number. We know that 3 plus 4. Or the only thing you subtract is in order to get the number of neutrons, not the nucleus, this N equals neutrons. This atomic mass is the nucleus. So you take the nucleus, you subtract the number of protons, and you get whatever the number of the neutrons. Do you see that? The nucleus is also known as the atomic mass. What's basic? What do you mean it's basically subtracted? Yes, but I didn't subtract to get the atomic mass. I subtracted to get the number of the neutrons. The atomic mass is the larger number. The atomic mass for lithium is 7. The number of protons is 3. 7, this is an algebraic equation. 7 equals 3 plus n. How do I find n? I have to subtract the 3 so that I can get n from both sides, exactly. What? It's minus the protons. Yes. What I said was adding is this. To get the atomic mass, you have to add the number of protons plus the number of neutrons.
Oh, that's deep.
So therefore, if I know the number of protons is 3, then my number of neutrons have to be 4 in order for me to get the atomic mass of 7. We are adding. We're adding protons and neutrons to get the atomic mass. We're subtracting the protons from the atomic mass to get the number of neutrons. Does that make sense? I think some of you are confused because the atomic mass is the number of the nucleus, not the neutrons. Yeah, but you're looking at me as if this is like rocket science, and it's not. Let's do another problem because some of you are still confused. Again, the atomic mass equals what plus what? Why are you up, Jamila? Protons plus neutrons. The atomic mass is also the what? Nucleus. It's the nucleus. The nucleus is the center of the element, the center of the atom. That's when we go back to this picture. We go here. The nucleus is the atomic mass. That's the center. That's the bulk. That's what it's made up of. When we look at this picture here, this center stuff, that's what it's made up of. That's its weight per se, its mass. That's the heaviness of it. This is the nucleus. This is the center. This is also gives you the mass. Like all of the stuff inside of you is what gives you your weight. It's your center, it's your core. So that's this protons plus these neutrons. We got that? Okay. So then when we look back at the periodic table, once again, let's look at chlorine. Well, what's so funny? Because I can stop and you can get the lesson all on your own and then do your homework, everything all on your own. Chlorine's element symbol is what?
CL.
Cl. Carbon is C. What's the atomic number for chlorine? Atomic number for chlorine. What is it? Say louder. Be confident. 35. So we're looking at chlorine. Chlorine's atomic. What's chlorine's atomic mass?
No, I just said it wrong. 17 is the atomic number.
Okay, good. That's nice you speaking up. So you need to be learning and know your stuff. I am your teacher. However, you have the resources here. I am not telling you anything. I am teaching you. You have everything in front of you. It is your responsibility to look and say, oh, yeah, that is wrong. Or, oh, yeah, that is right. Why are you waiting for me? You have it in front of you. And it's not like you don't have anything in front of you that is that's not clear. It's not something I have to teach you to look at it and see. So what's the atomic mass of chlorine? Atomic mass. 35. How many proteins does chlorine have? Protons. 17. How do we know that? Because it's the same as the atomic number. Thank you so much, Aaliyah. That is the educated answer. Plus the number of neutrons. Do we know the number of neutrons? No. But in order to find it, we have to subtract 17 from each side. Roger, you say subtract one more time. One more time. We are subtracting, but you keep saying it as if I was wrong to begin with, and I wasn't. The statement that I said to you earlier was absolutely correct. We are not going to argue back and forth. We're done. Get out and get your stuff and go. To Mr. Young's room. The lesson is online already. It'll be online in a moment, so you can log on and get it. I'm calling your parents because I don't like your attitude. 35 minus 17 is what?
18.
So the number of neutrons for chlorine is what? 18. Understand?
Yes.
Good. Let's look at your homework. Your homework is the one that says, who am I in a world? It's not the time to talk. If you look up here, you see the homework says the world famous table, who am I? It says, we had a lot of moving and talking. Come back and sit down. It says a world famous table / who am I because on the back it has the who am I portion. Let's just look at the front really quickly. Can I get a volunteer to read the first paragraph? Go ahead, Christasia.
There is a table not one for dinner. That's probably the most famous table of science. You can find a copy in your library. If you learn how to read it, you will have quick access to important stuff about elements. It's called the periodic table because it's written in rows called or periods.
Periods, good. Everyone should be filling that in.
Build your skill at reading the periodic table by finding the missing information in the sentences below.
All right. Look here on your chart. This is a chart that will help you through. It also helps test your knowledge. Take a moment and complete this chart. Nope, carbon is not the example. Carbon is just a guide of showing you how these blocks are listed. This is just the chart in general. Asking you the atomic mass is what? Like your notes. Atomic number is what? Like your notes. Number of protons is equal to what? Like your notes. That's why it says remember. All right, raise your hand and tell me what the atomic mass is. Jayla. It is the nucleus, but what is it? This is like math. What is it? Devin. Drew. P plus N, which is protons plus neutrons. I said this is a guide, a chart. That's why it says remember. Atomic number. Simon. Number of protons. Number of protons equals Brian. Electrons. Over here, this block with the C, this just shows you it's a key chart to show you that the number to the left hand corner is the atomic number. The letter in the middle is going to be the element symbol. The words underneath there is the element name. And the number underneath is the atomic mass. So let's do the first one together. For this one here, number 1, everyone, the atomic number would be 1. The atomic mass would be 1. Flip your papers over to the back. Let me explain the back to you. Can I get a volunteer to read the instructions? Go ahead, Janie. Thank you. So let's look at number 1. Actually, remember this. This is the remember part again. I'm not going to read that. You need to read it to help you remember. Let's look at number 1, which is the clue right here. Someone read that clue for me. Go ahead, Ray. Halogen.
Halogen family atomic mass 35.
So what would this be? What is it? Atomic mass. Chlorine. Very good. Flip your papers back over to the front for just 1 second. I need to make a correction. If you look over here with number 88, that should be radium, and the symbol should be R. This should be an R, and this should be radium. Look on your periodic table. You'll see the correct spelling for it, for 88. No. I'm just telling you here. It has the number right here, but it goes, if you go in order, you look for 88. They go in order according to the top number. So that should be R, and it should be radium. Any questions? All right, you have time to work on your homework. Get working.